Welcome all for my presentation. The presentation shows the Doppler effect of sound, light and the applications and the mathematical equations of this. The pictures good morning shows the positive vibrations of our mind. So, happy morning and welcome to all my presentation. I am Kokila from BME first year. Good morning sir and good morning to all. And first we see about First, we see about Doppler effect. What is meant by Doppler effect? Example: in we traveling in some place, the ambulance are coming opposite with you, or inside. The ambulance is crossing with you, and behind there are some sound makes so that uh, how the sound is observed with your ear, that is we study about here, that is Doppler effect. Come we see about this. The apparent change in frequencies or pitch either due to the motion of the source or observer. I said now, when the ambulances come towards you or go away you, that is Doppler effect. For example, we can observe this effect when we talk towards a loudspeaker producing sound in streets. When we go to the loudspeaker, we will hear high pitch, that is sound, and when we go away from the loudspeaker, the pitch becomes lower. The apparent change in pitch due to the relative motion because of observer and the source is known as Doppler effect. I said the ambulance here setting the loudspeaker. Yes, it's also correct. When we stand near the loudspeaker, its a volume so high, and we move towards that, the volume is higher. We away from that, the volume is becomes slower. There are two types of Doppler effect, that is sound and light. Doppler effect is found due to exchange in both sound as well as light. Doppler effect in sound. Next, see about Doppler effect in sound. Definition: the same definition, but the simple word is changed. The apparent change in pitch of sound. In Doppler effect, the pitch of frequency, here the sound. Due to relative motion of source of sound and observer is called Doppler effect in sound. Here the important word is observer, source, that is an important word in Doppler effect, and asymmetric property. A property. The property of in sound is Doppler effect in sound is asymmetric. Why is it setting asymmetric? In the sound, the material medium is necessary for the sound to propagate. So the extra change of bits of frequency, or hence the apparent frequency will be different in both the following case. When a source moves to the stationary observer, when the observer move towards the stationary source, thus the Doppler effect is a asymmetric, not a symmetric. Okay, this is an example. Take the ambulance itself. When we move to the ambulance, or ambulance to the ambulance to you, that only the process is. So it is a asymmetric. Let's come to see about the mathematical relations of Doppler effect in sound. Let we consider a yes, that is a source that produces a sound n. Let n be the velocity of the source. Yeah, because n is the velocity. Sorry, the source and observer are moving towards and away. B is the velocity of the observer. A is the velocity of the source and B is the velocity of the observer. N be the velocity of the sound. Then how to write the apparent pitch of the sound is case 1. When the source is moving towards the stationary point. Okay, source is moving. Okay, stationary point is the apparent pitch is given by, here the example is source means ambulance. Okay, ambulance is moving, observer means the humans. Okay, the source is moving towards the stationary point. Ambulance is you are standing in the road, the ambulance comes towards you. That the formula is n dash. Here n is the apparent pitch. N dash is equal to v divided by v minus a. V is velocity, so velocity divided by velocity minus a is the velocity of the source. Okay, because source is moving, so v divided by v minus a. Next, case 2. When the observer is moving towards the stationary source with the same velocity, then the apparent pitch is given by n dash is equal to n plus v plus b divided by v into n. Here same source is moving, that is ambulance is stay there with the sound, a human is moving. That formula is n dash is equal to v plus b divided by v into n. In sound there are more applications. There are Doppler effect in sound is used to find the velocity of liquids using ADV. How to okay, this formula only for finding a simple velocity. For a large, ADV is used. Doppler shift is used to convert a acoustic horn to the loudspeaker. Ultrasounding Doppler velocimeter, that is UDV, is used to measure blood flow rate. The blood flow rate is measured by UDV, that is ultrasonic Doppler velocimeter. The sonic echocardiogram is used to access the velocity of cardiac tissues. Sonar, that means sound navigation and rising, is used to determine the speed of submarines and the navigating objects under the sea using the Doppler effect. Using the Doppler effect, the submarines, that is inside the sea, they are traveling. To determine the speed of the submarines, it is used. This about the sound. Sound means there are two. When the source is stationary, the observer is moving, and the observer is stationary, the source is moving. The formula is 2. That's it. The application is 5. Next we see about the Doppler effect in light. Definition: the apparent change in frequency of light radiations when the light or observer move related to each other is known as Doppler effect in light. Symmetric property: Doppler effect in light is symmetric. Okay, why they saying symmetric? Because of, in case of light, we can't see the light in our naked eyes when either the source move towards the stationary observer. Okay, the light moves to the stationary observer when the observer moves to the stationary source. When the source moves away, towards and away is the word here, the important, away from the observer, and the observer moves away from the source, so it is called as symmetric. Mathematical relation for this, there are 4 cases in here. Case 1. When a source is moving with velocity v towards. When the source moves the velocity v comparable with the velocity of light c, then apparent frequency u v dash is equal to v plus v by lambda. or v dash is equal to we take v as common, so v is equal v into 1 plus 1 divided by lambda. Here v is equal to c by lambda or lambda is equal to c by v. So v dash is equal to, putting the c value here, so 1 plus v by c. Equations represent the source moves with the velocity comparable with the light. Next, case 2. Case 2 implies when the source moves from the stationary observer or the observer moves away from the stationary source, the velocity v. Then the apparent frequency is v dash is equal to v plus v by lambda. Taking v as common and put v value. C by lambda. V dash is equal to v to 1 minus v by c. The difference between case 1 and case 2 is a symbol, the plus and minus. Next, case 3. When both the source and observer are towards the velocity v and the apparent frequency is u dash is equal to v into 1 plus v by c the whole square. Here the squared is interchanged, the equation is 3. Then case 4 is when both the observer and the source move away from each other with the velocity v, then the apparent frequency is u dash is equal to v into 1 minus v divided by c the whole square. What is the applications of Doppler effect in light? Doppler effect in light is used to estimate the velocity of liquid flow of using LDV, that is laser Doppler velocity meter. It is used to find the velocity and rotation of the sun. For example, since no Doppler shift is observed from the light received from north and south edge of the sun, the sun is observed to rotate about the north-south axis. Doppler effect is used in navigating systems of marine, radar, surveillance, speed of automobiles, etc. It is used to observe the redshift, which in turn helps us to understand the concept of expanding universe. With the help of Doppler shift, double stars, Saturn rings, etc. were they discovered. Thank you for joining with me, sir, and thank you, my friends.